So in the last couple of videos, we've done a lot of graphing quadratics starting in the vertex form, where we find the vertex and then we used a pattern for increasing the y values each time x changed by 1. But we're not always going to start in vertex form, and it's going to be inconvenient to have to always change into that form every time we want to graph. So we're going to learn how to graph starting in other forms. The form we're going to be starting in this video is called the root form, and it's because it very easily gives you what's called the roots of the parabola. So let's take a look at a quadratic function like this. Now, we actually graphed this 2 videos ago, and we had to go through the tedious process of multiplying this out to convert it to the standard form, and then completing the square to convert it to vertex form. And that was just to plot the first point on the graph. Then we still had to graph all the other points. So there's something we can very easily do when we're in this form. We can say, how can we get y equal to 0? Because if y is equal to 0, we'll have a point right on the x-axis. And this is something we covered when we first started solving equations by factoring, where we had quadratic equations set equal to 0. What we can realize is that if either one of these terms, either x plus 3 or x minus 1, is equal to 0, then the whole thing is equal to 0, because 0 times anything else will still be 0. So we could make x equal to negative 3 to make the whole thing equal to 0, or we could make it equal to positive 1, because negative 3 plus 3 is 0, or 1 minus 1 is 0. So the 2 points here we're saying is if x is negative 3, then y is 0, or if x is 1, y is 0. So those are actually 2 points on the graph. So we can plot those first, and those are called the roots. The 2 points on the x-axis are called the roots of the graph. And when we're in this form, we can obviously get them very easily. So that gives us a start and shows the general idea of where we're going to be graphing. But we still need to find the vertex in order to find out where the starting point of the graph is. So we're going to have to do that. Let's do that up here. We're going to multiply that out to be x squared plus 2x minus 3. And now we're going to complete the square. Take half of 2 and remove the x, so we'll get x plus 1 squared. Take out the 1 that we've added. Bring down the minus 3, so we get x plus 1 squared minus 4. And so the vertex is the opposite sign of this number and the same sign as this number for x comma y. So it's negative 1, negative 4. So we can plot that point, and that is the vertex. That is where this graph starts. And now, just using those 3 points, we can get a very good idea of what this parabola looks like. We can see that the curve is going to go in that direction, connecting all 3 of these points. It's going to look something like that. Okay, so for this one, we are also in root form. Root form meaning we have 2 factored terms here. It's basically the standard form, but it's already been factored. And from this form, we call it the root form because it's very easy to find the roots. We just have to find, how do we make either of these terms equal to 0? Well, for the first term, to make x plus 1 equal to 0, we make x negative 1. For the second one, to make 2x minus 6 equal to 0, x will be 3, so we'll have 6 minus 6. So the 2 roots here are going to be y equals 0 at x equals negative 1 and y equals 3. So now that we have those and we see where the graph crosses the x-axis, we just have to find the vertex by multiplying this out. So we get 2x squared minus 6x plus 2x, so minus 4x minus 6. Now we complete the square. We factor out a 2 from the first two terms. Then change this into x minus 1 squared minus 1. Remember to close the outside parenthesis, minus 6. And this will be 2x minus 1 squared minus 2 minus 6, so minus 8. And the vertex will be positive 1, negative 8. So it's going to be way down here. So you can see we're going to have a much narrower graph looking something like that. Okay, so we're actually going to stop here because in the next video, the next part of this root form, we're going to get into something very different where we're actually going to be finding the vertex of the graph without doing the standard process of converting to standard form and then completing the square. And that's where you're really going to see how much time you can save by graphing with this method when you're starting in root form. Because in this video, we still had to find the vertex using the standard method. But in the next video, we're going to look at a major shortcut for doing that.